This is the second video lecture on Mann Whitney U-test. In my first lecture, I have explained the introduction to Mann Whitney U-test and when to use Mann Whitney U-test and assumption we need to follow for applying Mann Whitney U-test, and very importantly, steps to solve any problem in Mann Whitney U-test. So in this problem, I'm gonna solve equal sample size type of problem, and in my further video I will solve unequal sample size type of problems. Let us reminder the important steps we need to follow for solving Mann Whitney U-test problem. So very importantly, which is detailedly explained in my earlier video. So here first step is to combine the observation of two sample. You know that we have to consider two population in this, so we have to combine both population samples. After that, make a combined rank from smallest to largest, then apply test statistics. After that, to obtain a critical value and compare critical value with your tested value, and finally take a decision. These are the essential steps we need to follow for solving Mann Whitney U-test. Now let us consider a problem for solving that Mann Whitney U-test. So here we have a problem. In this problem we can see that the following data represent lifetime of batteries of two different brands. We have brand A and brand B, and respected battery hours are given here. For brand A, 40, 30, 55, 40, 40, 35, 30, 40, 50, 45, 40, 35, and so on. For brand B also same problems, data are given. So this is for brand B. So here we need to examine, is the average life of two brands is same at 1% level of significance. So brand A and brand B we have in this problem. So let us see whether the average life of two brands is same or not same. Before going to solve the problem, first of all we have to decide which kind of statistical tools we have to apply for this situation. So this is the case of two independent population, that is a brand A and brand B is a two independent population, and assumption of normality of both population is not given in this problem. So normality situation is not given, so we can't go for two t-test for two independent samples because there is no assumption of normality is given, and the data is also in the ordinal scale. So this is best suit for Mann Whitney U-test. Then let us formulate a hypothesis for the given problem here. So for formulation of hypothesis, here we want to test that the average life of two brands batteries is same. So if mu1 and mu2 denote average life of batteries of brand A and brand B, so mu1 is brand A and mu2 is brand B respectively, then our claim is mu1 is equal to mu2, because in the problem itself they have asked whether the average mean life of batteries is same. So our claim is mu1 is equal to mu2 and its complement is mu1 not equal to mu2. So here, since claim contains equality sign, here claim contains equality sign, we can take claim as null hypothesis and complement as alternative hypothesis. So our claim becomes null hypothesis, that null hypothesis is mu1 is equal to mu2, which means average life of two brands of batteries is same, and alternative hypothesis is opposite to null hypothesis. So that is average life of two brands of batteries is not same, and this is the case of two-tailed test, because alternative hypothesis contain two-tailed test. So this is the case of two-tailed test. So now let us consider second step in solving Mann Whitney U-test, that is combine the rank. Go by one. First step in Mann Whitney U-test is combine the observation. Since we are having two population here, that's brand A and brand B, we have to combine the observation given in the problem. So brand A, brand B, that combine observation must be in ascending order, that is smallest to largest value we have to combine. So firstly we have to identify smallest value among the both population. First smallest value is 30, so 30 here is here and 30 is here. So firstly I will mention both the 30 first in the brand A. After 30 we are having 35 here, only one more 35 is here, 235. So after 30 we have I put 35 in the next order. After that we are have to go for next largest value after 35. So 40, 40, 40, 40 and 40, we are having 40 value, that also I have put in a order in a brand A. So after that next largest value after 40 is 45. Only one observation here we are having in this brand A, 45, that is put here, that also put here. After that next highest observation is 50, only 150 is here, 50 is also entered here. And next highest observation is 35, 55, 55 is also entered here. So all the observation in brand A are exhausted so far. Now I will shift to brand B. In a brand B also I am going to order the data in ascending order. First lowest element in the brand B is 35. So here 35 is entered first. After that next observation, next highest observation to 35 is 40. Only 140 is here, that is also mentioned here. And after that one highest value after 40 is 45, that is also mentioned here. And for after 45 we have to go for next highest observation, that is 50. So we are having four 50s here, 1, 2, 3 and 4. So 4 observation also entered here. After 50 we are have to go for next largest value, that's 55. Only we are having 255 here, here one thing, here one more thing, and 2 observation is entered here. After 55 next highest observation is 60, 61, second 60 and third 60. So 63 values also listed here. So first step is over in Mann Whitney U-test, that is combine the observation of both population. After first step, now we have to go for second step, that is combined rank. After combining all the observation, now we have to give rank. Okay, so here already direct ranks are given. That working note I will show you in the right side. So ranks, firstly first position in the for giving rank we have to consider both population, that is brand A and brand B. Example, brand A value 35 is here and brand B, in the brand B also 35 is here. We have to combine both together and have to put a combined rank. That's why the second step is combine both population in the sense. So let us move from firstly we are having in the brand A 30, 30, and here in the brand B there is no 30. So brand A, in the brand A 30 first value, that's first position, second 30 is second position. So 1 plus 2 is 3, and since I have added 2 observation I will divide it from 2 only. So 3 by 2 is 1.5. So 1.5, 1.5. This is a, since there is a tie between two observation, we have added and divided with the respected observation. So next value in the brand A is 35. 35 is third position. 35, one more 35 is fourth position. And in the brand B also we are having 35, that is the sixth position. So this is first position, second position, third position and fourth position. This is fifth position. Now I have to add all together, that is all 35. First 35 position is 35, 3 here 3. Second 35 position is 4, here 4, and fifth 35 third 35 position is 5. So that is 3 plus 4 plus 5. Since we have to, why I'm considering this position, you must understand, since we are dealing with ordinal data in the Mann Whitney U-test, we have to consider only position. So we are adding position. So 3 plus 4, 7, 7 plus 5, 12. Since I have added 3 values, I will divide by 3. 12 by 3 is 4. So this is a 4 for third position, 4, 5 for fifth position, 4 for sixth position. Sorry, 4 for fifth position. So next value I will consider here. Consider that is 40. Since fifth position is over, 40 position is sixth. So this is sixth, this is 7, this is 8th, this is 9th, and this is 10th. And in the brand B also one value is here, 40 value. This is 11. So I have to add all together 6, 7, 8, 9, 10, 11. When I add all these together, I got 51. Since I have added 6 values, I will divide 51 by 6. Now I got that average. Average value is 8.5. So here 8.5 is given for 5 values in the brand A, and 8.5 is also given one value in the brand B. So that is 8.5 is a position value for a brand A and brand B. After 40, next value is here, that is 45. And let us search in brand B also. There is also 45. They here 45 position after 40 position. So 40 position is here 11. So 45 now is 12. So 12 plus 13. Here bring the brand B, 45 is 13. So add 12 and 13. Added together value is for 25. Since I added 2 values, I will divide it by 2. Added value combined rank is 12.5. So here for 45 12.5, for here for 45 12.5. After 12.5 we go for next value, that is 50. So now 50 value position is 14, because 12th position for this 45, 13th position for this 45. After that 50. So here this means 14th position, here 15, 16, 17, 18. So add all together 14, 15, 16, 17, 18. So when I added all together, I got 80. Since I added 5 observation, I will divide that added value by 5 observation only. So I got 16. So 16 is here, 16 for 4 observation in brand B. So after that last observation in brand A is 55. This position is 19 because here this position in the brand B is exhausted, that is 18. After that 19 here it is 20, it is 21. So 90 plus 20 plus 21 is equal to 60. 60 by 3 will be 20. So 20 for these two observation, here 20. So after that all values in the brand A are exhausted. In the brand B we have some values, that is 60, 60, 60. So 60 position is 22. This 60 position is 23. This 60 position is 24. Since there is a tie, I will add this 22, 23, 24 and I will divide it by 3. That is a 22 plus 23 plus 24 will be 69. 69 divided by 3 will be 23. So here 23, 23, 23. So far by using combination, we have given ranks for both brand A and brand B. For combination, we have considered both the rank. That is why we are calling this as a combined rank. After combined rank, we will go for total of any rank. Since we are dealing with the equal sample size, we can consider any one of the total. So I will consider brand A ranks total. So after adding all these ranks in brand A, the total value is 102. So I will consider that 102 for the calculation. So here N1 and N2 is both are equal, which means sample size are equal. So we can take any the sum of our ranks of first sample or second sample, whatever you can take. So here I will consider first rank. So by considering first brand A rank, I will test the statistics. Now then let's go for third step, that is test statistics. So here it is a result. So here it is a formula for N1. I have considered N1 formula. So U is equal to S. S means this rank, combined rank of N1, and N1 number of observation in the bracket, N1 number of observation divided plus 1 bracket close, in the denominator 2. So 2 means 2 population we are dealing with. So here S value is here, that is 102. I have considered S value is here, minus 12. 12 means 12 observation. Number of observation in this case is 12. 12 into in the bracket 12 plus 1 bracket close, in the denominator 2. So this is 12. 12 plus 1 13. 13 into 12. 13 into 12 will be 156. And 156 will be divided by 2. So when I divided 156 by 2, I will get something like 78. Now from 78 I have to subtract this S, that is 78. 102 minus 78 will be 24. So the tested value of Mann Whitney U-test is 24 in this case. So after this, let us move for next step. What is next step in this case is obtain critical value. We have to obtain critical value from the table. So here there is no, they have not given any alpha value. Since they have not given any alpha value, I will consider 1% for level of significance. So now let us obtain critical values of test statistics for two-tiled test, because this is since alternative hypothesis in this case contains equality sign. So this is a two-tiled test. For two-tiled test, for N1 12 and N2 12, let us obtain critical value. Since it is two-tiled test, that U lower limit will be that alpha will be divided by 2, that is A by 2, which means 1% divided by 100, we got something like 0.001. This is our critical value. Here this will be alpha by 2, this will be divided by 2. When we divide this by 2, we got 0.005, which means we have to see the table value for this value. For N1 and N2 12 degree of freedom, and for 0.005. Then let us see the table value, and this is a table value for Mann Whitney U-test. Now I will tell you how to read this. This column degree of freedom is 2 3, that is for N1, and this row degree of freedom for N2. And here in the bracket we have alpha, which is a level of significance for 0.001, 0.005. Like that we have different level of significances. So here our N1 is 12 and N2 is also 12. So let us see the degree of freedom for 0.005 level of significance. So N1 is 12. Here this is N1 is 12. And N2, this is N2 12, and for 0.005 degree of freedom, that value is 106. This is for lower, that is lower critical value. The Mann Whitney U-test table, we have lower critical value and upper critical value. Both kind of values we are having. Firstly, I am looking for lower critical value. So lower critical value, the value for N1 is 12 and N2 is 12. the lower critical value is 106. So for lower critical value is 106. Then let us go for upper critical value. So here this is upper critical value. Here you can see upper critical value. So in the upper critical value, let us see that N1 12 and N2 also 12. N1 12 and N2 12. So you can see here N1, here N1 12, this is N1, N1 12 and N2 is here 12, and for 0.05 005 degree of freedom here 194 for upper critical value. So for lower critical value 106 and for upper critical value 194. Now let us compare these critical value with the tested value, and finally we can take a decision. So critical value, I told you for lower critical value is 106. You know how I derived this for lower critical value. For upper critical value 194. Now let us compare with this value with the tested value. Our tested value is 24. So before taking decision, let us see the decision rule for two-tiled test. So here the U lesser than U-test lesser than or equal to U lower limit value, or U greater than or equal to U upper limit value. If it is a case, we will reject the null hypothesis. And when we do not reject null hypothesis, is U tested value of lower limit and U tested critical value of upper limit is greater than that U tested value, which means if the tested value lies between lower limit and upper limit, we do not reject null hypothesis in Mann Whitney U-test. So in this case, our lower limit value is 106, that is a lower limit critical value, and upper limit critical value is 194, but our tested value is 24. So since this 24 is not lying between these two values, we will reject this null hypothesis. So which means your tested value of U tested value must be lesser than the lower critical value and greater than the upper critical value. Then we will reject the null hypothesis. If your tested value lies between lower critical value and upper critical value, then we do not reject a null hypothesis. So this is you can see, since calculated value of test statistics U is 24 is less than both critical value lower critical value and upper critical value. Since it is lesser than both critical value, we reject null hypothesis, that we reject that climb at 1% level of significance, and then thus we conclude that samples provide us sufficient evidence against the climb. So average life of two brands batteries is not same, they are different. So thank you so much for watching this video. Now you can see this problem for solving the similar problem that I have solved here. I have given the same problem, you can solve this, and this is a reference material. In the next video I am going to cover the Mann Whitney U-test for unequal sample size. Thank you so much for watching.